I'm not muted anymore. Yay. Sorry about that. Hello. I hope you enjoyed The Offspring. Um, I just realized that this notepad file is needing to be pushed in a bit. So I know the spacing is now weird, but whatever. We'll do the best we can with it. Anyway, so just some announcements before we get started today. So today we're doing our last unit, but we're doing it over 2 days. So design patterns. This will be on Tuesday and Thursday. So today being Tuesday, should have just said today, but it'll be today and Thursday will be design patterns. I will go over a number of design patterns. There are substantially more than I can cover in 2 days. Originally, this unit was going to be 3 days, so I cut it down significantly. To that end, however, this material will be used on the final homework. I'm going to try to get to all the patterns on the homework today, so that way on Thursday when I'm covering design patterns, they're not related to the homework. So I got the homework up this morning. The homework is going to simulate the NCAA basketball tournament. Currently, I only have data for the men's tournament up, but I am working on getting data up for the women's basketball tournament. So that way you'll have both if you wish. But I'm trying to pull up the particular file that I want here, the particular 538 webpage I want. So 538 put together a, where's the bracket? Here we go. 538 put together this. And this is a simulation of the NCAA men's basketball tournament. So they used a bracket, a predicted bracket, since of course we never actually got a bracket for the NCAA tournament this year. It was canceled. But don't worry, you're going to simulate it. And this bracket, you can see how far each team got. So Dayton got to the Sweet 16, Maryland got to the Final Four, etc. And you can see that they claimed Michigan State would be the ultimate winner. You're going to make your own simulator. It's not going to have any graphics components. I've tried to strip out a lot of this assignment that I've used in the past to make it significantly shorter and simpler. But you are going to simulate the tournament and find a winner. Sadly, West Virginia did not get very far. Feels bad, man. Anyway, from there, I gave you 4 data files for now. You're going to get 8 total. There's the men's teams CSV file, the men's teams JSON file, the bracket CSV, and the bracket JSON. You'll see how those look when you open up the homework. But to that end, this homework is, you are allowed to work optionally with a partner. Now, you do not have to work with a partner. There are no additional requirements if you work with a partner. But because of the abbreviated timeline, I am going to let people work with a single partner. No groups of 3, full stop. If you do work together, to make it simpler for our TAs, both of you need to submit the final product, but you need to make sure that both of the partners' names are on the README and on every source code file. That is just to make sure that we, when we do grade 1, we give the other partner the same grade. So you are allowed to work with a partner. This homework is not particularly long. The key is going to be implementing it in a certain way with design patterns. Except I actually use most of these, not all, but most of these design patterns in homework 3 in the code I gave you. So homework 7's up. You're going to simulate the NCAA basketball tournament. The bracket file, I have a little explanation in the write-up. Certainly, if you have questions, don't be afraid to ask on Piazza. But again, you may work with a partner, but both of you submit the files independently on Colab. Are there any questions about homework? Oh, also, this is important. It is due next Tuesday. This is because there's a rule saying that I cannot let homework be due after the last day of class, because then we start getting into finals. However, I will not mark this homework as late let me fix my camera here. I will not mark this homework as late until Sunday, May 2nd. That means that if you submit Saturday, May 1, which let me make sure that I have the date correct. Excuse me, this should be Sunday, May 3. Sorry about that. So if you submit Saturday, May 2nd, it will not be late. However, if you submit on Sunday, May 3rd, it will be marked as 5 days late. If you submit Monday, 6 days late, etc. This is to basically give you more days to work on the homework without violating the rules. That said, I tried to make this homework as short as I can while still doing the things I want to do, which is implementing design patterns. Are there any questions about homework 7? It will be, of course, the last homework. And there will be a quiz this Thursday on architecture, integration, and design patterns. It'll be the last quiz. And our goal is to have all grades, quizzes, and homeworks up to homework 6 available to you by April 27th. That is next Monday, so that you can make a decision as to whether or not you want a letter grade or the pass-fail option. As a reminder, there is no C- grade anymore. If you have a 70%, that is a C, not a C-. So that would map to CR, not GC. GC being general credit. It would map to credit. Any questions? All right. So let's take a minute and let's talk about what design patterns are. The idea of a design pattern is not something that exists in programming uniquely. Design patterns are shared ideas or memes. A meme is just a shared, repeated idea. But when we think of a bridge, we talk about suspension bridge, and there are certain patterns that all suspension bridges follow. And those patterns exist because they've proven to be effective. So these are often considered best practice. They're repeated ideas that appear in a number of bridges. Design patterns, when we're talking about software, are just repeated ideas that appear in a lot of software that give the software a predictable, easy to understand structure. And that's what we're doing here. Not every pattern is suitable for every situation. I'm going to reveal design patterns over the next 2 days that you may not use in this class. In fact, on Thursday, I'm going to reveal some that you almost certainly won't use on the homework. You're welcome to, but you probably won't. And to that end, these patterns are just different tools in your arsenal. If you need a screwdriver, you're not going to automatically use a hammer as well. You're not going to use every design pattern in every project. Rather, you are Batman. Batman has a lot of tools on his utility belt. He has batarangs, and he has grappling hooks, and I can't remember any other tools that Batman has, because those are the two he seems to use the most. When Batman needs a grappling hook, he uses a grappling hook. When he needs to scale a tall building or pull something to him, he uses a grappling hook. He does not use batarangs for that. Similarly, when he needs to hit a bad guy at a distance, he uses the batarangs. The point being, use the right tool for the right situation. Not every design pattern is going to be used in every program you do. But again, these design patterns are just repeated ideas, repeated memes that show up in a lot of different programs. And all the source code I'm going to show you today has already been uploaded on Colab. And that source code has a lot of different parts. Oh, I forgot to upload Observer. I will do that later. But I have a lot of different design patterns here. The only one I forgot to fill in was Observer. Today, our goal is to cover Singleton, the factory design pattern, specifically the factory method design pattern. the strategy design pattern, and then given time, we'll talk a little bit maybe about adapter. But these, again, are just repeated ideas, and I have demos of them here. And actually, I've used some of these in Homework 3, especially the factory design pattern, so you've probably seen that one before, so we can get through it fairly quickly. Not super talkative today. No questions yet. Interesting. Well, we'll see. So broadly, our design pattern breaks up into 3 groups. We have creational design patterns. These have to do with how an object is instantiated or created. That is to say, rather than having the user directly call a constructor, we have a class whose job it is to make instances. Structural patterns are about combining existing classes into a structural format, how we combine different classes, how we connect different classes, etc. And then behavioral patterns are a way to give manifest to a flexible behavior. An example of this is the strategy design pattern, which we'll talk about later. Are there common ones that every engineer knows? I mean, every engineer doesn't know anything. If you get the sum total of all the knowledge that all engineers share, that's probably going to be I think, therefore I am, and nothing else. Presumably 2 + 2 = 4, but I don't want to make any assumptions. There are opponents to design patterns, but the reason I don't agree with them is that as we get into software engineering, we're talking about improving methodologies of software engineering. One of the things we need to start doing that other engineering practices do is start thinking about structured problem solving in ways that similar problems can be solved in repeatable ways. Now, software has very little repeatability. Unlike much other production, software production is generally ad hoc, which is to say that the specifics of each project are unique enough that you can't reuse most of the code. But we can use the same ideas over and over. And for people who say it's overly complicated, typically the root cause of believing it's overly complicated, and I don't want to say always, but typically the root cause is generally a lack of understanding of inheritance. That tends to be the biggest problem, the biggest hurdle. To that, I say the solution is better instruction of inheritance. It is not... You're kind of blaming the design pattern for something that underlies, I think, a problem in CS education. So that is to say, there are certainly people who are going to think certain design patterns are bad. There are some people who are going to go so far as to say all design patterns are bad. I don't agree with the latter. There are some design patterns, because keep in mind, there aren't design patterns are not something that was etched on a stone tablet that fell from the heavens, right? There's something we as human beings made. And some of those principles may actually be more complicated than helpful. I'm not denying that that's possible. I would say most design patterns are very good, and I have found practical uses for every design pattern I know. But that said, I'm not going to vouch that just because you slap the label of design pattern on something that it's inherently good. That said, I am going to go over some common ones that I think you should know in class today and on Thursday. That's a good question, though. There are people who are going to say, design patterns, it's a waste of time. I don't agree with them. Anyway, an example of a design pattern you have certainly used before, implicitly or otherwise, is an iterator. An iterator is a behavioral design pattern that allows you to loop over all elements of a collection at one time. And this idea of an iterator is so prevalent that if you make your own collection, you should make your iterator for that collection. So if you implement a collection, you have to implement an iterator in Java. That is to say, if you implement the interface collection, one of those things is implementing an iterator. So you use why do you use iterators when you can use for loops, while loops, etc.? Hopefully you know the answer to this, because sometimes you might be looping over something like a set or a binary tree, like a tree set, or a map. You may be looping over keys or values where there's no clear indication of a first or last element. And now you may be thinking, but wait, I've done things like, and let me just, I'm going to pull this up for now. Just ignore the rest of this code. You may think that I've done things like public static void main string args, set s equals new hash set. Let me do set integer. And you may think, okay, well, I've done things like this, and then let's say add a bunch of stuff here, and then for integer I in S. And you may think, well, that's a for loop. This for loop actually uses an iterator. The reason you can't do this on something like a JSON array is because JSON array actually has not implemented iterator. I don't know why they haven't, or iterable, I should say. Technically, it's an interface called iterable. I don't know why they haven't just added that feature, but this is not angry rant time, so I'm just going to skip it and say this actually uses the iterator from set. So the iterator design pattern is incredibly present, and the basis of the iterator design pattern is to visit every value exactly once and no more than once. And a key advantage is functional independence and information hiding. I don't have to know how a collection is structured to use an iterator. It could be a list, set, binary search tree, or something cool I haven't even thought of. It could be something like a skip list or a Bloom filter. Those are some cool data structures that you may have learned about. But the point is, I don't need to know how those work. I don't need to know how those data are structured. I only need to know how to use the iterator. So that promotes information hiding. I don't have to know how the underlying data structure is structured. And functional independence. However it's structured is irrelevant because the iterator handles it for me, and I just use the iterator to visit each element. Further, if I implement an iterator, that is to say, if I design my own data structure, I should implement iterable, and I should write code that generates an iterator object. That's so that way other programmers can use my data structure and be able to visit every element once without having to know any more or have the risk of mucking about with the internals of the data structure. So if I make my own data structure, I should go to as much effort as I can to use that. And this gets the idea of why does everyone use this thing called iterator? Well, Java has tried to standardize iterator with the iterable. And the reason is that is a meme. The idea is very often you will need to take a data structure and visit every element exactly one time. That's a meme. It's a repeated idea that has proven to be useful for communicating a point. That's exactly what internet memes do. It's admittedly not as funny as internet memes, but it's the same idea. So unlike Millhouse, so iterators are memes. Millhouse is not a meme. And if you don't get that, that's okay. I'm old, and my memes are equally old. So the iterator design pattern, it promotes information hiding, and this should say functional independence, although also abstraction technically. This is built into Java as the interface iterable. Iterable is not a SAM. It's not a single abstract method. It has two methods. It has hasNext, which returns a Boolean, and it has getNext, which returns the next element in the data structure. The data structure supporting generic typing, we get E in this case. And this, by the way, throws an exception if there is no next. Typically, it's a no such element exception. Um, but you can, again, just always have a safety check of has next, where has next returns true if there is something left in the iterator, or if the iterator's at the end of the data structure, it returns false. And by the way, you can have more than one iterator for a class. So generally, the iterator object belongs to the iterable. So the iterable might be something like my own array list. Like let's say I write my own array list that has some limited optimizations that are uniquely beneficial for my code. Maybe I want to do like a ring buffer array list. That object would implement iterable. So this would be my array list object. It will have a class iterator, but this class iterator, it iterates over the abstract iterable. Now keep in mind, I may have two, this iterable may be abstract. So this may be like the abstract list, and then this could be array list, and the iterable 2 could be linked list. But the iterator works the same way. It uses effectively the data structure to uses details of the data structure to iterate through it. So this would be a design pattern for the iterator. So again, do you have to use design patterns? The short answer is no, you don't have to. You don't have to use an iterator. But using an iterator makes your code more maintainable. And the reason it's more maintainable is it allows you to switch the data structure later on, maybe to something more efficient or something more customized. And if you use the iterator, you won't have to make changes. So it improves the internal quality of the software. Any questions about iterator or justification for why the iterator exists? And again, these slides actually aren't uploaded yet, but they will be. But the source code is uploaded that I'm about to show. All right. So now, let's talk about creational patterns. Creational patterns are patterns that hide or limit use of the constructor of an object. That is to say that we maybe put up a curtain such that an outside user can't use the constructor. And there may be reasons we want to do this. We'll get to some in a second. This could be true if an object requires a special process to create it. Maybe it needs to be created only under certain circumstances. We can limit that by hiding the constructor. And by hiding the constructor, I literally mean make the constructor private or make the constructor protected or put the constructor in a scope that the client, that is the user using the design pattern, is not aware of. Forgive me for 1 second. I'm going to have to go just for 1 second. Something urgent's happening. I apologize. Sorry about that. I'm back. Okay, so with that, we're going to hide or we're going to limit how a constructor of an underlying object is used. Let's take a look at an example. Let's say I needed to write my own, because obviously we've talked about log4j before, right? We've talked about how to use log4j, but let's say you wanted to write your own logging client, your own logging program. Well, consider the needs of a logging program. If your program has something that can log, you're going to have any number of classes needing to dump information to our log file. And we want all of our tools dumping that information to the same place. So we want, let's say, every class that's logging to log to, say, one file, or maybe one of two files, or one of three files, whatever. The point is, there could be any number of classes in our system already that need to log, and it could be that as we add new classes, they also need to access the logging tool to log information to a file. So we want to make this logger easy to use, but we want to limit how many instances can exist, because what we want to make sure of is that we're not creating a situation where every class needs their own logger, because that's not maintainable. That's creating a proliferation of classes that do the same thing. At that point, we're effectively talking clones, which we talked about are bad before. Another problem is if a programmer calls the constructor of the loggers, well, this logger is going to have a file stream. If we create a new logger that tries to create the same file stream, we have a problem, because programming languages generally limit you to only having one tool accessing a file at a time. Even if you could get around that, you would certainly run into race conditions. So how do we solve this problem? Well, we can solve this problem by any class that needs to log never calls the constructor. Rather, we have a method that returns an instance, the same instance that every other class is using for the logger. And here's what that looks like. And it's called a singleton. And a singleton is a creational pattern, and it is a class that contains an instance of itself, a static instance of itself. And actually, I should make this private for the sake of time. And it may contain some attribute, maybe that's a string. It could contain any number of attributes. The field, it could have as many field variables as you want. In this case, I only have one, it's a string. And the point is, if I look at this string variable, I always want every file that accesses the instance of singleton to be referencing the same string. Maybe it's the same file reader, because maybe this is, instead of being a string, is a file reader or a file writer object. It writes to the same file, whatever. The point being, this is a variable that belongs to the instance, but I only want one instance to exist at a time, hence the name singleton. Well, so if you'll notice, the first thing right out of the gate here is this constructor is private. That means no one outside of the class singleton can call it. So how do we create an instance if the constructor is private? Well, we do it through the getInstance method. And this uses lazy initialization. So if the instance has not been created, we create an instance. And then we return that instance. From there, we have just a standard getter-setter method for this string attribute that returns the attribute and that sets the attribute. And we have this class singleton demo. This is going to get access to the singleton object. It's going to set the string to hello world, and then it's going to print that string. From there, I have another class. And generally these classes are named intentionally kind of overly verbose. Another singleton demo. And this calls the constructor for another singleton demo. This singleton demo gets the same instance, because there's only one instance that exists at a time. It also has effectively a setter for that string and something that prints the string. Going back to singleton demo, you can say I then do ASD print the string, and it should print hello world, because that's what the current value of the string is. I did s.setString. And then from there, I set the string to hi mom, and if I print s.getString, that is this class's singleton, well, remember, this s singleton is the same singleton as this s. They're literally the same memory address. They are equals to each other. So if I run this, I should get hello world, then hi mom. Let's go ahead and run this. Hello world, and hi mom. Prints hello world here because I set the string to hello world. It then, in another singleton demo, when I call asd.printSingletonString, remember this singleton is the same as this one. They're literally the same object. So when I print the string, it's going to also print hello world. And then I change the string to hi mom, and then I print the string and I get hi mom. So that is the singleton class. And the standard structure of this class is this private static instance and the private constructor. And we only create the instance inside this getInstance method. So if the instance already exists, we just return this private static instance. And if this instance does not exist, then we create an instance and return that. So this is useful because at the start of our program, we'll create a single logger, and then any program, any class in the entire program that needs to use the logger, all it needs to do is say something like logger_l equals logger.getInstance. And then that logger may have functions like write to file, etc. And I'm expressing specifically the logger because that's what you're going to do to implement a logger in Homework 7. So I'm kind of giving away the game of how you're going to do that. Any questions about the singleton design pattern? It's fairly simple, but the advantage here is it lets you make sure that only one instance of a given object exists at a time. And by the way, this isn't just used for loggers. This would often be used for something like settings. If your program has, say, a list of settings, when the user goes to the menu and changes those settings, they may manipulate this instance, but then those settings have very broad application of the program. Changing a setting in the settings object could change any number of classes. And so often settings are stored as some kind of singleton. All right, moving on. So again, just to briefly reiterate, make the constructor private, only allow one instance to exist. This is the key, this getInstance method. Log4Java, by the way, is implemented as a singleton. That's, if you notice, there's a logger.getInstance function. And notice that this function is static. So that means that you call it on the class. Going back to the code, you'll notice that this is singleton.getInstance because it's a static method. So only one instance can exist at a time. Client-side UI settings, service locators, logging, these are common uses for it. Never use a singleton, of course, if you need multiple instances because you can't have them. Now, technically, you can have things like a doubleton where you have exactly 2 instances or 3 or whatever, and you can make that work, but generally, I don't see that often, if ever. Generally, I just see a singleton. The next one we're going to talk about, you've actually definitely seen before in Homework 3. It's a factory design pattern. Specifically, it's going to be a concrete factory. So an example of this is, and I'm going to pull up the code here. An example of this is, let's say I have this program main that gets a tweet counter. And that tweet counter is going to use a tweet reader factory. Why? Well, the tweet reader factory is going to produce a tweet reader object. Well, the tweet reader is an interface, or excuse me, not an interface, but an abstract class. The tweet reader is just an abstraction of what a tweet reader does. It says, okay, there's a function called read, and it returns a list of tweets. How that function is implemented depends on where your tweets come from. So, for example, your tweets may come from a database, at which point you're going to open up a SQL database and download them, which you now know how to do. Not that you're not doing that on the next homework, by the way, but you would know how to do it if you needed to. Similarly, we have a tweet file reader. This would read through a file. And the point of this, let me make sure my camera is not in the right place at the moment. One sec. By the way, Colby Bear being extra fluffy today. Aww. Give me one sec here. So the idea of this grabbing my markers here. Is that we have some abstract class. Some abstract class. This is abstract. And I'm just going to call this some kind of abstract tool. Let me adjust the camera a little bit. Sorry. All right. And this abstract class is going to be implemented, that is realized, extends by two concrete classes. So for example, we have concrete. By concrete, I just mean not abstract. Tool 1, concrete tool 2, and without loss of generality, we could just say there's n of these concrete classes. Now, there's going to be some program that uses this tool. That is to say, it has a dependency to that. Maybe it's a dependency, maybe it's an ownership. It's one of these two. For now, let's just say dependency. That's going to use this tool. Now, what we want is we want the user to use this tool without being aware of the concrete implementation. This is the abstraction paradigm we've talked about. But the problem is if the user needs to create an instance of concrete tool or concrete tool 2, that is to say if they need to call the constructor, then necessarily they will be using these classes. So we want to find a way to remove these two arrows so the user is not aware of the underlying classes. And the way we do that is through a factory. The user is going to create a factory. And the factory is going to use these two concrete classes, but it's going to return, so it returns a tool, but it creates the concrete classes. And just for clarity, I'm actually going to change this to blue here. Just because there's a bit of an overlap, a bit of a crossing. And the user is going to get the tool by using the factory. So this is the idea, and this is the client. And the client is just anything that uses this class. So an example of this is in this program, tweet counter is a client. And tweet counter is going to get a tweet reader from the factory. So it creates a factory. And remember, this is a dependency because it's not an instance variable. It gets a tweet reader factory just by creating, and the tweet reader factory should generally have a 0 argument constructor. It then calls some factory method, and this method is going to take in some piece of information. It can be technically anything. It doesn't have to be a string. It could be an enumerated type. It could be an int. It could be an object, whatever. But it takes in some piece of information and decides which implementation, that is, which of the concrete implementers of tool is being returned. Now let's take a look at this tweet reader factory class. And you can see that this is going to take in some string. If the string is equal to file, it's going to produce a tweet file reader. If it's equal to DB, it's going to be a database reader. And an example of where I use this on homework 3, if you go all the way back to homework 3, is I look at the file and I determine whether it ends with CSV or XLSX. So I pass in the file name here. And if the file name ends in CSV, it returns a CSV reader. If it ends in XLSX, it returns an XLSX reader. This is the factory. But this factory can only return one data type. It can't return either one data type or another. It can still only return one data type. And so we necessarily have to use abstraction here. We have to say there's an abstract class tweet reader that defines a method read, and that there are two concrete implementers, file reader and DB reader, that implement that. Now, obviously, I haven't implemented these here. I'm just saying return null. These are stubs. But this is just to illustrate the structure. So in this case, and by the way, tweet in this case is a POJO. So technically, again, it's like a database record. We can think of it not much different than a string, and we can pass the tweet back and forth. Doesn't matter. But tweet counter is the client. Tweet counter uses a factory to generate the reader. It does not directly call a constructor. Tweet reader, therefore, does not need to be aware that these two files, DB and file reader, even exist. The client doesn't need to be aware these files exist. It doesn't need to be aware of what the constructors are or how they work, or where the data is coming from. The client has no awareness of this. Never calls the constructor directly. Only the factory needs to be aware of this. And that therefore isolates these two classes, where the only classes that need to be aware of these two concrete implementers are here. That is to say, they need to be aware of themselves, and the factory needs to be aware of it. Even the abstract class doesn't need to be aware of the concrete implementers. Only the factory does. So we limit all of the dependencies of understanding how to instantiate the object to the factory, and any class that needs to use a tool does so by interacting with the factory. So we separate the client. Notice the client, again, has no awareness. You can think of this line, I'm going to draw a line here. You could think of this line like a curtain, and the client is never aware of anything behind the curtain. This allows me to add things behind the curtain or change the interface of things behind the curtain without the client needing to be aware. And again, you can take a look at my the starter code for homework 3 for an example also of how that's implemented. Are there any questions about the factory method design pattern? Any questions about that? I do also want to point out, there is another design pattern that is similar, and it's called the abstract factory pattern. The abstract factory pattern is significantly more nuanced. It is rather specialized. I was going to teach about it, but because of the fact that we effectively lost today at class, that's one of the design patterns I'm sacrificing, because it is rather complex. It is rather esoteric as to when you would use it. But the only reason I point out that there is such a thing as the abstract factory pattern is the factory pattern and the abstract factory pattern are different patterns. They are kind of related, but not really. They're very, very different. So if you're trying to look up anything online about a factory pattern, make sure you're not looking up anything about an abstract factory pattern, because they are rather different. And the abstract factory pattern is significantly more complicated and significantly more nuanced as to when you would use it. All right, the last design pattern we're going to cover today, and this is, and by the way, on the homework, you have to implement a 3-tier architecture, which I've taught you. You have to implement a singleton, which I just taught you, and a factory pattern, which I just taught you. You also need to implement a strategy, and then you'll be ready to go for the homework. So what is a strategy design pattern? Well, you've actually used strategy design patterns before. Remember when we talked about comparator and comparable? That was way back. Let's see if I even... Actually, I won't have that project on here. We've talked about how if you have... and again, I'm just gonna add this here. If you say had a list of tweet objects, tweets equal new array list, and let me import java.util.list. You can, and again, let's say I add tweets here. You can do something like collections.sort tweets. And if you do this by default, it will use the tweet, and technically I would need to say implements comparable tweet to be able to do this. Doesn't like comparable rabble. Let me add in, I'm just going to add a blank method for now. You could, by default, sort the tweets by their comparable, but you can also define other ways to sort the tweet. Let's say that by default, the tweet sorts by timestamp, but you want to sort the tweets alphabetically. Well, you could do something like comma, new tweets alphabetical comparator. And this class is going to implement comparable tweet. And we add in this method here. Or sorry, not comparable, excuse me, comparator tweet. Excuse me. I did that wrong. So this comparator function, or this comparator class, excuse me, is a class that lets you define how to sort other objects. And you can do things like collections.sort, and then you create an instance of the comparator class, and instead of sorting by the tweet's comparable function, that is the compare2 function, it will sort by this class's compare function. And this allows you to design ways to sort objects on the fly. And we did examples of this with Lambda bodies too, where you can define something like collections.sort tweets, and then it's so you define some compare function. This would take in tweet A and B, and then return A dot text dot compare to B, something like that, or B dot text, and that would sort the strings not necessarily alphabetically, but in ASCII order. This is actually an example of a strategy design pattern. And the idea is we have some object that effectively serves as a wrapper for a function, like when we do functional programming. And that function is passed to something that then uses that function to decide how to perform some task. An example of this that I have is, let's say that you wanted to create some shopping cart. You were making, say, an online website that supported some type of shopping cart feature. And that shopping cart is going to have some list of items. So it's going to create, when you initialize, create that items as a new array list. You can then add items to the cart. You can also remove items from the cart. Pretty straightforward, right? Then we have a function to calculate the total. This just loops through the list of items. By the way, this is using an iterator, so there's the iterator again. But calculates the sum. The item object has a getPrice function. And then we have a function called pay. And this takes in something called a payment method. Now, this payment method is a payment strategy type. And this payment strategy type is specifically an interface. And with strategies, because we're doing generally like functional style programming, we tend to implement this as an interface specifically, not an abstract class. And the payment strategy is simply going to define a method, pay int amount. So this takes in some amount, and it produces a payment, or performs the actions of a payment based on that amount. I have a number of things implementing this. I have a credit card strategy, which implements payment strategy. I have a PayPal strategy, and then maybe I could add something like a cash strategy. Now, these are classes. They have a constructor, they have fields, but the key is they implement this payment strategy. So, for example, if someone gave a PayPal strategy, now, by the way, never implement a function this way that actually takes in an email and password. You would technically do a certification certificate, blah, 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 blah. Point being, let's say it were implemented this way. This would take in an email and password. The pay function may do something to verify that email and password. So maybe technically there's, verify email and password. Forgive me, I'm getting an ice pick headache here. Give me 1 second. I get sharp pains in the head when I'm wearing my headset sometimes. Alright, it's passed. Sorry, if you've never had an ice pick headache before, you know it is named apropos. It's a very, very sharp pain, and because I wear glasses, I get them a lot because it's pressing on the side of my head. Verify email and password, some code to do that. And then you perform the payment. And then this is just printing, say, a confirmation message. The credit card strategy, instead, we don't need the same information. We don't need a username and password. Rather, we need a credit card number, the security in this case, we need the name on the credit card, the name as it appears on the card. We need the credit card number, which technically you could implement as an int, but actually you couldn't implement as an int because it's a 16-digit number. You could do it with a long, but an int, you're kind of capped at 2 billion, so you technically would need to use a long, but this is why often it's stored as a string. A string for the security code, and then a string for the expiry date. And then in your pay method, you would go to the bank, you would charge the credit card, and then similarly print this confirmation. The point is, both of these classes effectively do the same thing. They process a payment. But how that payment is processed depends on if we're using PayPal or a credit card or maybe cash. From there, we have a shopping cart demo, and just to illustrate how this would work, I would do something like create a shopping cart, add 2 items to it, and then I could either do cart pay and then a new PayPal strategy, or cart.pay and then a new credit card strategy, something like this. And if I run this code, technically it's going to pay both ways. So let me just go ahead and run this here real quick. And you'll see that I get the confirmation both ways. The point of this strategy, the point of the strategy design pattern, is it lets me decide at runtime how I want a particular task completed, where that task is defined by this interface. So, going back to the slides, I may have something like this. And just to illustrate how this design pattern works, the idea is the shopping cart has a payment method of some kind. That payment method is determined at runtime. So at runtime, we're going to either pick by Visa or PayPal or a mobile payment. And each of these classes may have a constructor that takes in information, such as the credit card number or the phone number or the PayPal account, whatever. And then at runtime, we call the shopping cart, we'll just simply call payment method.pay. And whichever payment method is being used, either the Visa, the PayPal, or the mobile payment, that's the pay method we call. This is, again, similar to how the collections.sort method works when you pass in a comparator. At runtime, you can select different comparators, and the action will be performed with the comparator that you choose at runtime. Another example of this, let's say I wanted to loop through a list of things. And this thing, so thing objects. And this thing object has a name and an ID. Well, it could be that I determine the equals method based on the name or the ID. I could decide at runtime which I want. Well, all I would need to do is define an interface. Let me move this. Define an interface called equal checker. Excuse me. This is going to define a single method, abstract method, called equals. And then I can create two implementers, one that uses the name and one that uses the ID. And then at runtime, and let me actually real quick, this slide is animated. So at runtime, dang it. At runtime, I could pass in an equals checker object. That is to say, if I'm doing this linear search, I can decide if I'm searching for the name or the ID. So the structure of the linear search is independent of how the elements are being compared. It doesn't matter if I'm looking for the name or ID from the sake of the search method. The point is, I'm looking for something that's equals based on some criteria, and so I pass in the equals checker. I then loop through this list of things if the equals checker eq dot equals t, or that is to say that thing t is equal to the target object thing, then I return true. And this allows the client to determine at runtime how to compare the elements, whether they want to compare by, say, name or by ID. So these are all examples of the strategy design pattern. And on the homework, what you're going to do is you're going to use a strategy design pattern to determine how to simulate a game. So there are three ways on the homework that you are going to simulate a single NCAA tournament game. You are either going to use, and by the way, the homework uses something called ELO score. ELO is a simple metric that means the bigger the number, the better the team is. That's all we generally mean from it. And the ELO score of the team with the higher ELO score, that is the better team, will always win. That's the first strategy. The second strategy is rather than the favorite always winning, you do a probabilistic randomness. So if, let's say, you expect the winner to win 75% of the time, generate a random number. If it's less than 0.75, because random numbers are 0 to 1, if that random number is less than 75%, then the favorite wins. If it's greater than 75%, then the underdog wins. That's the second strategy. The third strategy is pick a favorite, where the constructor will need to take in a name of a team that always wins. And if that team is in the matchup, we are going to pick that team to win. Otherwise, we will use a random sort. And this is all outlined in the document. But the point is, you should now have your gears turning on how you can do that with a strategy design pattern, where at some point you're going to have a function. You're going to have a function like this one that takes in some type of takes in some kind of match resolver, or whatever you want to call your strategy class. So that is the strategy pattern. Are there any questions? You guys have been really quiet today. I've only had one chat message the entire day. Are you guys still there? Am I alone? I can see who's in chat. I can see like the list of users, so it's people being quiet today. Anyway, it must mean that I'm explaining things incredibly well. Yeah, course enrollment is stressful. I'm very well aware of that. It is difficult, and especially when you don't know if the classes are going to be in person or not. All right. Well, I tried to make this homework. I originally had written this assignment actually before spring break. I wrote it a year ago, and I nip-tucked it earlier. And after I realized I'd only have a week to do the assignment, I shrunk this assignment by about 50%. So I tried to make it, before you'd have a bunch of different options and a bunch of different features, and now you basically have one feature done 3 different ways. So I did try to make this assignment more reasonable, and I did try to give a reasonable timeline for it. I hope it's not difficult code, and the key is just you're focusing on implementing design patterns, and they're not super difficult design patterns. The goal here is just to get you to do it once, and then once you do it once, hopefully they stick in your mind, and later on you think, oh, I could use a factory pattern here. Oh, I could use a strategy pattern here. That's my only goal. So I tried to make the assignment relatively short. For context, I wrote it last night from scratch in about an hour and a half. Now, granted, I know the design pattern, so I'm going to be faster, but truth be told, it wasn't that long of an assignment. The last thing I'm going to talk about today, and we're going to continue with design patterns on Thursday, I want to talk about anti-patterns. And an anti-pattern is a pattern that is both common and bad. That is to say, can you combine these design patterns? Absolutely. So we'll talk about the bridge design pattern on Thursday and how it lets you combine patterns. Technically, an abstract factory pattern lets you combine multiple factories. But yeah, you can combine these patterns. So on the homework, for example, you're going to do a singleton, you're going to do a factory, and you're going to do a strategy. Technically, those are on 3 different parts of the system, so they're not really working together. They're just doing 3 independent facets of the system. But you can absolutely combine patterns, sure. But anti-patterns generally have a negative effect, mostly on the internal, but sometimes on the external quality of the system. An example of an anti-pattern that is extremely common is this. Let's say you were doing this. This is bad because you're doing manual string concatenation. You're taking a process that should be linear time, and you're actually making it O of n squared time, and this is because of how Java concatenates strings. Instead, you should use a string builder object, and then use string builder.append to add things. And that's because the string builder uses an array list, and so you get amortized linear time. Or should say amortized constant time for each add, making the whole project, the whole loop, linear time. The other anti-pattern, and this is more of an architectural design pattern, and it's an architectural design pattern. It's not really an architectural one. It is called the big ball of mud. And the big ball of mud is when you don't plan an architecture. You just start writing the code and building the system without any plan as to how new elements will be integrated. You just build things and just stick them onto the project. And this is the most common anti-pattern. In fact, the big ball of mud is the most common architecture because the architecture is not planned the big ball of mud doesn't have a planned architecture. So the best way to think of it, if you've ever heard of the game Katamari Damacy, that's what this is. Except instead of being a thing of wonder, your project will be an entropist piece of crap. It will be something that you're just not able to add to. And yes, you are allowed to steal the insult, Entropist piece of crap. If you've never seen Katamari Damacy, and it seems people are stressed, let's just go ahead. Katamari Damacy gameplay. The idea of Katamari Damacy is you start with a small ball and you roll up things, and if they are smaller, you can pick them up, but if they are bigger, like that tree, you don't pick them up. But as your ball gets bigger, you can pick up bigger and bigger things until you start picking up much bigger things. And then, hang on, let me get to... Actually, here, I'll just go to Katamari Forever. This is the final level. You start rolling up entire countries. And then eventually you start rolling up entire planets and the entire cosmos. Now, what does that have to do with this? The point is, it gave me an excuse to show off Katamari Damacy. If you've never played it, it's really fun, and it's actually rather relaxing. But it's also a good metaphor for what the big ball of mud is. As things are added to the project, they're just rolled up, and there's no form or plan. They're just added to the project, but it makes the project harder to impossible to maintain. The last anti-pattern I want to talk about is the God class. And the God class is one class that is aware of every other class in the system. You actually want to avoid this, and that's intended. The point of a 3-tier hierarchy is to make it impossible to have a God class, and that's because this class, because it has so many relationships, will get too complicated to maintain. That's because every class you're aware of, you can think of the complexity of the system growing quadratically. Each new class you add adds more complexity than the last, and so generally, we want to avoid this, and we want nice hierarchical structures, where each class is only aware of the classes it needs to be aware of, and sub-dependencies, that is, classes those rely on, are invisible to the parent class. So with that, we're about at time, so I'll go ahead and end there. Take time to look at the source code. If you want, you can use a partner for homework 7. You don't have to email me or tell me. All it means is just at the end, make sure both your names are on every source code file. Make sure both your names are on the README, and both of you submit. So, like, if Steve and Jane work together, both Steve submits and Jane submits. It just makes it significantly easier for us if you do that. And then from there, we will try to grade that as quick as we can. Of course, we're not going to have the grade for homework 7 by the time you have to decide whether or not to accept the letter grade or accept the pass-fail credit. As a reminder, there is no C- in the class now, so 70% or above is a C or better, which means CR or credit. A 60 to 70% is a D- to D+. That is going to be the GC, the general credit. And then below a 60% is the no credit or fail. With that, if there are any questions, certainly feel free to ask them. Otherwise, I will end the stream here. And again, I'm just going to leave this up because this is, I think, this is going to be kind of the critical part of the assignment, the strategy design pattern. By the way, the intro was, I'll just show it. The intro music was this, and this is Mario Paint Composer. So way back in the day, there was a game on Super Nintendo called Mario Paint, and it had a little music editor in it. Someone effectively reverse engineered that editor and made a separate program and added features like sharps and flats. But so this lets you play music. For example, this is Offspring's Why Don't You Get a Job? Hang on, I gotta. I find it amusing. Also, I love the Offspring, so it works out quite well. All right, well, I haven't seen any questions, so I'll go ahead and end the stream here. Thank you all for watching. Get started on homework 7, and I will see you Thursday with more design patterns. Thursday is the last lecture for new material. Reminder that next Tuesday will be exam review, and I will try to get a study guide up on Friday just to highlight what will be on the exam. I don't remember what the exam day is, so let me check. Just like the first exam, you will have it should be a 12-hour window, or maybe it's a 16-hour window. I can't remember what I did on exam 1, or exam 2, excuse me. But the final exam, you will not only have a 3-hour window, you'll have multiple hours, 12 to 16, somewhere in there, to take the exam. But I need to figure out what day that is, because it's still the day on the final exam schedule, which is, so we're a Tuesday, Thursday, 12:30, so that's 8. So that's going to be Tuesday, May 5th. So that is going to be Tuesday, May the 5th, and technically it says 2 to 5 p.m., but it's going to be obviously open for a bigger window than that. So I will see everyone next time. Take care.